Hello and welcome to the overview of Agile Software Engineering at SAP. This is really about advanced programming techniques for Agile or iterative development, so especially in Scrum mode or any kind of iterative process. The Agile Software Engineering course teaches a set of advanced technical practices to developers that improve quality and development efficiency at the same time. This course has now been given for 2 years, over 2 years, and over than 3,000 SAP developers worldwide, and we still have excellent feedback. It's complementary to and well integrated with lean and design thinking, and in this presentation I want to give you an overview of the key content of the course. We all know there are many ingredients for successful software projects. The first, of course, is expert developers and domain knowledge and all these other things. But there are two main dimensions of success. One is to do the right thing, and that has to do with requirements engineering. And this is where design thinking falls into the place. And on the other side is doing it right, where it's about building it right, the software quality, internal software quality, and so forth. And that's where Agile Software Engineering plays. You may think or have heard this, that Scrum is enough to build good software, and it does certainly help a lot. But it is a framework that really focuses on project management and who is doing what and talking to who and so forth, but has no technical practices inside. And so what still can happen is that in spite of doing Scrum, your projects can still fail. And the reason is that you may deliver features to the outside, but if you don't focus on the internal quality of your software, you're still in trouble. And basically this is the learning of not just SAP, but the whole software engineering world out there, that there is a complement needed, and that is the agile engineering practices to complement Scrum and to really make Scrum or really any other iterative development process really work well. Now I want to give you an overview of some of the key elements of the course and how they work, and especially also why they work. The first one is test-driven development, or also called test first. And the key idea really is that you write the test before the product code. Now this may sound strange, but it gives you a lot of surprising benefits. Let's look at the picture on the left-hand side to see how that really works. Let's assume you have a requirement that takes a couple days to do, say let's say 3 days. That's on the stack of requirements, and you take that, and of course now you're working on this. And even though you may have something that is working, that takes a couple days to do, there's always one little next step, something that you want to make work now that didn't work before. Let's say you want to make a function, give you an answer for a new set of parameter combinations that didn't work before. And so instead of writing the code and then testing it, you write the test first. So you write a test that tries out the new parameters, and of course it fails because it is not implemented yet. So you have at this right circle a failing test, a unit test of course. Now you write the product code, and only enough product code to make this one test go green, and then the test is green that you just wrote, but also all the other ones that you wrote before. And so now you know that the new thing works, but also the other stuff that you wrote before, and nothing has been broken by your changes that you made, which is also very important. And now these little cycles, they're typically quite fast. So you would have maybe every 5 minutes, every 10, 15 minutes, that you have a new unit test driving a new feature, a new piece of product code. Now developing in this mode gives you a lot of benefits. Some are surprising. The first one is it gives you trust in your code. Why is that? Because these small tests that cover just small little steps give you a very high semantic coverage of your code. So you don't have 10,000 lines of code in 2 test cases, but pretty much everything that the code is supposed to do has been challenged, has been required by a test, and also is now covered by a test. So you know that the behavior of the code is really captured by the tests that you wrote. And therefore basically you know that your code works when the tests are working, and they're all green. The second thing is that the tests are documentation of the developer's intent. So if somebody asks, how do I use this API, you just look at the test. It's a very good way to start also for API documentation and so forth. Another point is that it has a good design impact. Why? It's because if you drive your tests from the outside through the API, that gives you are the user as a unit tester, you are the first user of your API, and you immediately see if something is missing or something is odd to use. This is much different than developing an algorithm from the inside out and the API more or less evolving from the inside out. And the last point is that because now if you have a very high semantic coverage, so the test really captures what the code is supposed to do, it enables you to change code and clean up, and we'll come to that in a minute. Two interesting quotes about this from practitioners who have been doing this for a while. So one said that test last didn't help because it takes too much time or too much effort to make the code testable afterwards, and therefore it is often not done. This has to do with the design impact that testability of code comes when you develop it test-driven. If you don't, then it's very hard to add this later on, and we'll see in a minute more details about that. Another thing that you can ask is, okay, do I have the time to write tests? And especially unit tests, is it not effort that I could save? Well, first of all, you have automated tests, so if you write unit tests at all, you should do it before. This is basically the essence of the first quote. But the second thing is really that you save lots of time in the debugger. If you develop test-driven, you hardly ever need the debugger anymore, because what the code is supposed to do is required by the unit tests, and therefore you're not during development analyzing and stepping through the code so much, but especially later on also in defect analysis when you have any problems, the unit tests point typically very exact to the source of a problem, so it saves you a lot of time there as well. Now you may have heard this quote that is considered the wisdom of software project managers: never touch a running system. And it used to be true, I suppose, in the past when you don't work this way, but now I would consider it wrong. Why? Well, because we learn as the software evolves, or as a developer, when you start to develop something and you do it for a few days and you realize you are done, most of the time at the end you learn something on the way where you say, well, if I had known this before, I would have done it a little differently. And this happens on a developer level, but also it happens on a system level when it's on a larger time scale, of course. And if you look at the right-hand side picture there, it's something like this, where you have a starting point and you want to get to this result, and because you didn't know exactly what way you're supposed to take, you take these detours. So sometimes you can't do certain things, so you have to do a workaround, and you build workarounds and workarounds. And so you end up with a crooked path instead of a clean, straight path. Now, if you see this at the end, say, of a couple of weeks, or even at the end of months of development of a whole team, you realize something should have been done slightly different. Can you afford to clean it up? No way. Nobody would dare to take everything apart again and clean it up just a few weeks or so before the release to make the code nicer, because people say, well, nice code is not worth anything, we pay for functions. That may be true, but good, clean code is the only code you will survive with. And why is this? If you do TDD, test-driven development, it gives you a very tight safety net, what I call semantic coverage. So the test covers the behavior of the code. And this enables to refactor, which means I can clean up the code. I have a test that captures exactly and checks how the code is supposed to behave. So if I take one little detour out after the other, and I always just press the button, let all the unit tests run, I can one by one take workarounds out. I can clean up things. And these can be small things like moving, extracting code, extracting duplicate code, things like that. Renaming is very simple. But also bigger things where the responsibilities of classes are shifted and so forth. And all this refactoring, in the end, it allows me to avoid technical debt. Technical debt is something like the legacy, the past that slows me down more and more. And in the end, it's all about one goal, and that's sustainable pace. So as developers individually, and also as a team, as a product, we want to be able to add features to a product at a reasonable speed and not become slower and slower as the product gets older and the code gets older. Now another key topic is really test isolation, which is the key to testable software. Just imagine you're responsible for that orange box on the right hand side, and you're supposed to test this, but you're depending on all these other components that have to behave a certain way or need certain master data or need this and that setup so that you can test your component. Now you can imagine that your tests become very expensive if you, for instance, have to set up an SRM system with master data or another system that does workflow and have a huge system setups, so that you can really run through all your cases, so to speak, and these become very expensive. What can be done about this? This is what really test isolation is all about. And I want to show it by a small example. Let's say you have a stock application there with a list of stock, a portfolio, and a list of stock. And each stock, of course, is a current value. And you want to know how much money do I currently have. So you have a quote service that goes out to the internet and gets the current values of the stock. And of course, this whole thing, you want to test this. Now, of course, this is trivial because you're just adding numbers, but it will show the principle. Now, the red arrow there already indicates where our problem is, because we're depending on something that's out there in the internet. That is pretty much the worst case, but something we do not own. And there are several problems with that. So first of all, the call may be expensive. So maybe a stock value check doesn't cost anything, but a credit check may cost something. So when you test it, you may actually have to pay money. You don't get stable values. Whatever you're calling may be under construction, not available all the time. It is definitely much slower than what you have internally as a small unit test, and you cannot provoke it to raise exceptions. For instance, you cannot say to the quote service, hey, give me a -1, I want to see how my code behaves when I get a negative value or a timeout or things like that. So you see that these dependencies to an outside component, the quote service, make it really hard to test your code. And typically also very expensive. Hard means expensive. So what can we do? Well, look at the picture here where the stock depends on the quote service to get the values that they need, and we want to cut this dependency to the outside, to the internet. What we do is we isolate the interface of this class. These are classes, objects, if you will, and we want to isolate at that point. And instead of calling the real quote service, we want to call a so-called testable. That is like, it pretends to be the real stock quote service, but it doesn't go to the internet, but it just returns a value that we tell it to return beforehand. So in this case, for instance, just return that one variable x. So the stock object doesn't know that it's actually talking to the testable when the code runs. And so the test case instantiates the testable, tells it what to return, and then calls its scenario. The code runs, and instead of going to the internet, it will go to the test doubles, and I can very quickly and very cheaply have all kinds of situations that I can simulate, so to speak, of the dependencies that I have from my code to other components. Now this allows me to test my code very well. So basically, that is, the unit of test can be tested very thoroughly and all kinds of combinations without depending on a whole expensive setup of other components that get more and more expensive. Another key element is pair programming. Pair programming is really two people and one computer. And there's two roles, a driver and a navigator. The driver has the keyboard at the current time, and the navigator has the cup of coffee. Well, actually, they can, of course, have both coffee, but the point is the navigator is not typing and so forth. That's what the driver does. The navigator thinks about the broader picture, but they discuss really together the code, how it should be designed, what is currently done. Did we forget a case or things like that? So basically, it's two people discussing the code that is written directly. And this is not like a one-day assignment or so, but the keyboard shifts right and left every 5, 10, 15 minutes. So these roles switch very frequently. And so in the end, you have two people working on writing the code. Now, this sounds very expensive, and we'll come to that later, But let's look at the benefits first, what you get from this. First of all, you get typically quite, I wouldn't say necessarily much better code, but you get simpler design. So it makes a difference to talk with somebody um, about the code that is written and immediately do a basically code review on the job when it's written. So you don't do it afterwards, which also takes a lot of time, but you do it directly when it's written. And that gives you typically simpler design. Another thing is that when people work together this way, there's a whole new level of knowledge and skill distribution in a team. So people learn from each other little tricks, but also things about the domain, pitfalls that they didn't know before. And actually, this is something that raises especially younger developers, or younger not by age, but not so experienced in the domain or technology or whatever, to expert level quite fast. So the whole team output goes up by this effect. Another thing it does, it reduces the risk of single code ownership. So if somebody's on vacation, you don't have to worry that you cannot fix a certain type of bug because the only person that knows what happens there happens to be on vacation. Another thing is that if you do want to write code in a different manner, so for instance, if you say I want to start introducing TDD and the team decided let's do it this way, your bad conscience is sitting next to you all the time. Well, not all the time, but when you do pair programming. So it's much easier to change habits basically if you do this together and talk about it. And finally, an aspect that has been reported a lot by people who've done this is that it's a great thing for team building. And team building and communication and this feeling of unity is actually a surprisingly big factor in overall productivity. So there's a lot of benefits that are kind of subtle to this. Now you may think, again, coming back to this point, is this too expensive? Two people that doesn't cut the productivity in half. There's typical stories from people who are doing this say hard problems go faster, very clearly with two people, and you do save if you do code reviews at all. If you don't do them after the fact when most of the code is written or all of it really, and you don't really want to do many changes anymore, you talk about it up front and you have much more freedom. So basically you're shifting the review part to the beginning, and you include knowledge and skill distribution and so forth, and these other things, the learning effects. Also, we do not say that pair programming should be done 100% of the time, but typically the average for high adopters, so people really who are doing this a lot, is to do it about 60% of the time. And that's when you, in development, that's a good quota of where you have really interesting design problems and code development problems that is much, it's much more fun actually to do together. How this works in practice, at many times in the daily stand-ups in the morning, somebody will say, I'm starting this topic, who wants to join me? And then the pairs are rotated, and new pairs will be found according to topics, and so it's not very strict and defined who's always pairing with who. It rotates a lot. The interesting thing is that the general testimony of people doing this, that there is basically no net time loss by this practice. Another element of the course is exploratory testing, which is, I think, really the only smart way of manual testing. It's been developed by a guy named James Whittaker. Used to be a professor and then was at Microsoft. I think he's at Google now. And it is basically a midpoint between the continuum of ad hoc testing and scripted testing. So if you look at the pictures on the left, there's on the one extreme you have something you just sit down, you try to hack on the system to see whatever you find, and you find some bugs maybe or not. There's no plan, and then very little output normally from the test. On the other extreme you have scripted testing, which maybe you have 20 pages of instructions and screenshots and enter this here, and so forth, big scenarios, and it takes a lot of time to write, it takes a lot of time to execute, and in the end there is some check instructions, is there a 3 here, is this button green, and whatever. But it's a large scenario with a lot of effort, and it gives you only one little line in a very big space. So exploratory testing is kind of in the middle, and it uses the tester's knowledge in a much better way. Instead of having a script that defines exactly what's supposed to be done, it's 100% deterministic, if you will. You have just a time box. You say, I spent 2 hours. I want to test this wizard. That is the scope. I will write a protocol. So I will write down what happened, but in a very concise way. And the new element really is the test tour. This is how do I test. And basically this is specific types of testing approaches find specific types of bugs. And this is where the power of this exploratory testing comes from. And they're called tours because it's like a tourist metaphor. You're going to a city, you want to see certain things, you can't see everything, but you focus on something. And so there are different tours that focus on different things. And for instance, at the top left, if you look at the landmark tour, let's say you want to visit a certain set of landmarks, but you don't care in what order. Now for software testing, it means you want to vary the order on purpose, which means you will find state-dependent, sequence-dependent bugs. So instead of going 1, 2, 3, 4, 5, like most people will do this, you will go 1, 3, 2, 4, 5, or whatever order, maybe go back and forth, and then you will find defects that have to do with the sequence of things, with the state that is accumulated in those steps and so forth. Another tour that is well liked is the supermodel tour, where you only look about the looks, not about the functions. So you could look about UI consistency guidelines, just is the button aligned and all these other things, but don't care about the function at all. So it's basically a visual checkup. Also one of the favorites is the anti-social tour, that you try to behave like no other user. So if everybody goes through a wizard in one sequence, you go in a very different way, or everybody says okay and you say cancel everywhere and so forth. And you find a lot of defects that way as well. Now what happens is that when a feature is built, this is the way it's done in the teams that are doing this. Typically they say everything that has a user functionality that is end user visible, it needs an exploratory test. And depending on what the feature is, they will pick some tour, maybe 1 or 2, 3, that are appropriate for this type of feature. So you pick the style of testing according to the feature, and it's also just part of the test backlog. So in the teams it happens that somebody else in the team, not the developer themselves that wrote the code, will pick that test task and do an exploratory test. Now this is a manual test where really the human brain is really the key, of course, and it's very efficient. Now this comes to another point actually, that we talked a lot about automation, about unit testing, and there's also higher levels of testing which we didn't cover now, but there is of course integration testing and so forth, and all these you want to automate as much as possible. But there's also the exploratory testing, which is the human element at the top, and everything goes together. So the course doesn't say we only need one, but everything goes together. But the focus is on unit testing. You want 100% coverage there, pretty much code coverage. Less so on the higher levels, and exploratory testing, the manual part, maybe 5% of the test effort, where you look at the human aspect of things, of the software. Now these were some of the key elements of the course. If you look at the puzzle piece, there is a few. If you look at the puzzle there. Now these were some of the key elements of the course. If you look at the puzzle pieces, there are of course other elements in it, but that were some of the key elements, like I said. I now want to look at the course itself. The course is a 5-day course. If you look at the picture on the left-hand side, and there are different flavors for ABAP, Java, C#, and so forth, because there's a lot of programming and tools involved. There are different flavors or tracks, as we call them, where you learn these principles, how they're applied in a certain environment. And what happens is teams are trained as a whole, and there's theory units, the green ones here, typically 1 hour only, and then 2, 3, 4 hours of practice afterwards. So typically 60-70% of the whole course is programming practice, where you practice the things that you just learned in the theory units. And so the whole team works. The whole team works together to build a small game application where they practice the concepts that are covered in the course. Now, after the 5-day course, there is something else, and that has been proven to really be also a key element to the success, and that is coaching. What happens is that the trainer or coach that teaches the team afterwards goes into the team for 3 weeks in addition, where the team goes back and works on their own things, but the coach helps them to apply those techniques and practices in their own environment. And this gives you, so the team just gets their own team backlog, but in this time really tries to solidify the practices that they learned in the course, and especially apply the more difficult topics with the help of the coach in their own environment. This coaching has been, like I said, proven to be very important to make these practices stick. We've tried in the early times also some early pilots without the coaching, and basically the course was almost without effect. After a couple months, people totally fell back into their old routines. So it's really an important thing. The feedback from the course is very good. So of course at the end of the course people are, these are some quotes from at the end of the course where they're quite excited about the content and haven't felt the pain yet of applying it in their own environment, but that's what the coaching is for, and similar quotes are also found at the end of the coaching period where we also ask for feedback. But as you can see here, developers like it a lot. Now I want to give a few short words about a survey that we did and where we looked at basically two things. For over 1,000 people that have done this course and had done it more than a year ago, so they had some time to practice. We asked them two sets of questions. One, really, how much are you practicing the methods taught in this course? So for the specific methods, how much are you doing of this and this, and so forth. And the second questions were about the benefits. Now the first, you see here that basically the trained techniques stick after a year and they're applied in practice. So things like test-driven development, pair programming, refactoring, automated test coverage, which is more of a result. If you look at the third column, the top 50% of adopters, which means like the top 50% who are doing it the most, their average is 61%, 33, and so forth of this practice. And like I said earlier, test-driven development and pair programming, the target for these practices is not 100% necessarily, but more like 50 to 60% in this case. So you can see that half of the people really operate at what the industry and we consider as the target values. So the practices really stick. The second question was, a set of questions really was about what the benefits are. Because we have expected, of course, certain benefits, and what the teams, and including the product owner, said is that 75% said that Agile Software Engineering really produces much better quality. 59%, almost 60, said that without impact to the development speed, and 29% said even with a speed gain. So about 30% of the people actually gain speed, and this is something that also can be explained and understood because of how these effects come together with a stable code line, pair programming, learning of the team, and so forth. There's also other positive impact to other team aspects like task focus, motivation, common understanding that you can see below. The last point is also quite interesting, that it's less stressful for developers at the end of the sprint, but also much more so even at the end of the release. And this is not just for the developers, but also the PO and managers that always fight at the end of a release to get the product out. And there's a lot of bad surprises. And one quote from one of the projects who's been doing this quite intensively said, one developer said, it was release end and we didn't even notice. There was no pain, there was no, even in ramp up, there was nothing serious that was found, and the code line was stable, and they do have hundreds of users now, a totally different experience than their previous release.
So in summary, we can say that Agile Software Engineering is a mature initiative at SAP. We have about 5,000 developers trained at this time globally in different flavors of the course. The course does teach state-of-the-art Agile development practices. So in addition to Scrum and project management aspects of working together in a development team, all the technical skills that go with it and are necessary really to work well in an Agile environment. And as we have seen, the benefits are substantial, so you can really gain quality and productivity and have less risk all at the same time. Now, this ASE ABAP course is now offered to SAP customers and partners as well. The value proposition is the same as we use internally for the internal rollout, of course, and is just that you train your developers to write better code, so to get all those benefits that we looked at before, to gain speed and quality at the same time, and learn the modern techniques and tools that are necessary to do that. And it's really applicable to all customers and partners who do significant development or extension projects in ABAP, meaning custom development, add-ons, but also standalone products on the ABAP platform. The general delivery concept is that we offer a training to teams, but also train the trainers as needed, depending on the size of the development organization at the customer site. So if there is many developers to be trained, it makes sense, of course, to have some local people who are trainers to do the actual scaling. And therefore, a typical ramp-up training on site is to train 1 to 2 teams, plus local trainers and coaches, or coaches, we call them the same, in one sitting, and then the local trainers educate their peers according to their own schedule. You can contact us through the email that is shown below. The details of the engagement and what is recommended and so forth is quite dependent on the circumstances, so that has to be really discussed one-on-one. And there's also a website where you see the link below that has more information and some white papers and stuff like that about this training itself, the benefits, and also the course offering. Thank you very much.